In this short tutorial, let's focus on lenses. We'll focus on two kinds of lenses, convex lenses and concave lenses. Convex lenses are lenses that bend outwards. So this is convex, bend outward this way. And concave lenses bend inwards like a cave. Both these lenses behave in different ways. So let's have a look at how they behave. So a convex lens, as shown here, bends the light, refracts the light to a single point called a focal point. So as light is shone into the lens, from the air into the glass and through the glass, the curvature of the lens causes the light to all refract in a particular direction and focuses the light. So we say the light is being focused down to a single point called the focal point or focus. And the distance between the middle of the lens and the focal point is called the focal length or the focal distance. It's interesting to note that the curvature of the lens, that's how curved it is, determines how close or far away the focal point is. And a very simple rule here is the thinner the lens, so the thinner the lens as shown here, the further away is the focal point, so the greater is the focal distance. The fatter the lens, or the greater the curvature, the shorter is the focal distance, the closer the focus is to the lens. So the fatter the lens, the closer is the focal point. The thinner the lens, the further away is the focal point. For a concave lens, what a concave lens does is diverge the light. So rather than converge it to a point, it diverges it. That is, they move away from each other. So we see the light shining into the lens here. The curvature or shape of a concave lens refracts the light, that is, bends the light so that it moves away from other beams of light going through the lens. So we say that the light diverges. And interestingly, the focal point of a concave lens is actually in front of the lens, back here. So there's kind of a virtual focal point. If you were to trace these rays of light back this way, you get a virtual focal point in front of the lens. Some of the uses of lenses are shown here. You've got something as simple as a magnifying glass, which is a single convex lens that allows you to focus light onto an object, but it also allows you to magnify objects depending how far away from the object the lens is held. You've got camera lenses. So the lenses you attach to the front of a camera have multiple lenses built into them to allow you to focus on objects close or near, close or far away. You've got things like contact lenses, which can be put into the eyes to replace reading glasses or glasses that allow you to focus the light properly in your eyes. You've got natural lenses. A natural convex lens is found in your eye, which is able to change its shape and allow you to focus objects that you see onto the back of the eye, the retina. So there are multiple things. Telescopes, of course, allow you to see objects that are very, very far away by using powerful combinations of lenses inside the telescope. And finally, on this slide, you can just see a couple of quick applications. So here's your magnifying glass. It can be used to focus light down to a single point. So if you focus light or heat down to a point, this point here, of course, at the focal point, gets very, very hot or very bright. Here you can see a couple of arrangements of lenses that can be used in telescopes to see objects that are a long way away. And you can investigate this more on the net if you're interested.